In this video, we're going to be going through a wire EDM tutorial on how to cut part like this from a piece of stock. So just a rectangular piece of stock. So I'm going to start off by right-clicking on CAM defaults and go to New Job. And then from here, I'm going to choose Wire EDM. And I'm just going to scroll down. I'm going to use the Sodic Mark 25 for my machine, but we have the defaults in here. You can pick the machine you have. If we need something more, we can add a new machine. You're going to want to talk to the tech support department. So I'll just go with that Mark 25. And then I'm going to go create my stock. And the stock wizard works essentially the exact same way as the milling stock. If I have a workpiece, meaning I have a solid model that represents this geometry, then I can pick it. But you'll notice I don't have a solid model. I could use a solid model, but I don't have one right now. The only time you really can't use a solid model for geometry is when you're working on a lathe part or a turn part. But in this case, wireframe is going to work, or a solid model. So I'll go ahead and say next and just ignore that. And then right here, it creates our piece of stock. So right here, I can see it is 9.5 by 5.5 by 1 inch. And I'm just going to leave it right there. Scroll down to the bottom. If we wanted to change the orientation of that stock, if it didn't match up perfectly, then we could change that. But I'm just going to hit next. And then right here, we can go and pick our origin. So where are we basing all of our code off of? So I'm actually going to leave it right there at XYZ0 because I'm using that area. I'm going to be cutting a hole there to plunge into anyway or feed my wire through and then go and cut my part. So I'm good with it right there. And so I don't even have to set up the origin. And the only thing I'm going to do is lift up Z, just say 1.5 inches, and then I can hit OK. After I have the stock created, I like to just right-click on the word stock and say blank, unblank. And then if I expand that, I can see what material is currently selected. And if I want to modify that, I could just say edit and choose a different material. You can also, depending on your machine and post, you can also open up a database that lets you change all the information for this. But I'll go with a 10 thou wire, hit OK. And then with this one, we really just have kind of one setup for this. A lot of these are going to be inside cuts. So I'm going to right click on my machine setup and I can see what types of features I can make. So we have a 2-axis inside, meaning it's a 2-axis cut, just vertical walls, and they're inside cuts. We have a 2-axis outside, so that's going to be for the outside of the part. We have a 2-axis open, which would allow us to do just a specific open area. Or we get into 4-axis. And we're not going to do any 4-axis here. It's essentially the same settings as doing a 2-axis, except for you're picking multiple pieces of geometry. If we had a center pocket that was a 4-axis, we'd have this center pocket here, and then maybe a wider one because it's got a taper to it. So I'm going to start by going and doing a 2-axis inside, and I'm going to select my geometry as these inside shapes here. So I'm just going to pick all of them right here. So we're on 7, 8, and 9. And then all the points that are on the inside of that, those are going to be the points we use to say start here and feed to the wall. So we'll have holes drilled in all those locations. So I can then go in and look at each one of my chains and see where the arrow is at. So if I want to pick a different start point, I can. So for that one, I'll put it in the middle. The rest of them are circular, so I'm really not too worried about it. And then I could go ahead and just hit OK. Now, when I hit OK, I could just go next. Right here, we have our stock thickness. We have the location of our upper and lower guide, which you may or may not need depending on your machine. Some machines use this, others don't. Right down here, we have our choice of whether or not we're going to do glue stops with or without leads, or whether or not we're even putting glue stops on the part. So your glue stop is an area that before it finishes cutting the entire part, when you still have a tab left, it's going to let you go in and add a stop distance. So essentially where we stop, so we get a chance to either glue the part or drop a magnet on it so the parts don't fall out. In my case, I'm just going to say no glue stop. And then right here we have our taper settings. So the taper settings are either none, so we're going to get a straight wall. We can add a taper to the geometry, and we can tell it whether it's a left or a right taper based on whether it's a negative or positive value, and whether we taper from the top or the bottom. Right here, we also have the ability to do land and tapers, so we can have a vertical wall and then the taper. But in my case, I'm just going to go with none, just a standard cut straight through. Then I'll say next. Right here, we get our choice of doing different types of cuts. If we left glue stops, you would get one extra cut, which is a tab cut. And so in this case, because it didn't leave tabs, we have a rough cut and then our skim cuts. Now, if you want to do multiple skim passes, you do not have to add in multiple skims to your operation. What you're going to do is just leave one, because when we get to the skim pass, we get to tell it how many skim passes we're going to use. So I'll go ahead and say next. Right here's our wire information. So it's a 10th wire, whether or not we enable starting cutting conditions or a rapid feed rate. After that, we'll hit next. Right here's our posting tab. So we have our spline or arc output tolerance, which I'll leave it at a 1/2 thou. That's fine. Our work offset number, and then our posting order. So we could say finish in individual shape or go by operation. So go do all the rough passes, then all the skim passes, then everything. I'm going to go with individual shape, rough it, skim it, do what we need to do in that one shape before moving on to the next. Right here we have our machine sequencing. So how do we organize the order of this? Closest is going to start at whatever position we select here and go to the next closest cut. No sorting seems random, but it actually runs in the order that you pick the geometry in. Or we could say, let's just go across the X direction or the Y direction. So I'll say, let's go X direction, start from the upper left-hand corner, and we'll zig. Next, I then have my parameters. So I can either do a standard profile cut, so we just cut our way around, and the part's going to drop out. Whatever slug we have is going to fall out. Or I can go with a coreless. And coreless for me really depends on the hole that I'm trying to make. It's usually going to be a hole because I have the ability to go in and drill a hole and then have this kind of clean up the rest of the hole. So if I have a 1/2 inch hole in my part and I've drilled a 1/4 inch hole in it, I could have a coreless cut basically go in and kind of pocket it and take all that material out. Or I could go in and just do a standard profile. So I'm going to go with the standard profile. I have system compensation turned off because I want my G41 or G42 to output depending on what direction I'm running in. I want to leave that one on. Right here, if we apply stop points are literally just points on your path that tell the tool when to stop. So you can either resync, do whatever. It's a stop point that just stops it. I don't have any selected, so whether this is on or off is not going to change the tool path. Right here we have our corner types, so we could go with a sharp corner. We can go with a round corner. We can make a loop radius, a loop length, a triangle, or a bisected line. And we have them both on external and internal corners. Right here we have our leads. So if we had a 1/4 inch hole drilled into that 1/2 inch hole, so we've already had a 1/4 inch cut, especially with the coreless, this is important. I go in and tell it what the diameter of the hole is that I have already there. That way it doesn't do that coreless cut from the center of the hole. It does it from the edge of the diameter. So it does it from where the hole is drilled to. But I'm going to leave that at 0. I have a thread wire, whether we thread it automatically, vertically or not. And then we just have some leads. So we have circular leads. We have perpendicular leads. We have a perpendicular blend, so it actually adds a radius to the corner. We have parallel. And then right here we have select point and point blend. So select point just lets me pick a point. It goes from that point to our start location and it starts its cut. You could even say perpendicular to the closest wall. Or you can go in and do a point blend. So we still have the points, but now it's going to add a radius into that cut. So for me, I'm just going to say select point and then pick points. And I'm just going to go in and pick all these points that we drew earlier. So I'm just going to add all these in. There should be one right here at XYZ0. We'll grab all these as well. And now it knows where it's going to start from. So I'll go right there and then hit OK. Now, after we have all those points selected, you're only going to see one, but it does remember all the locations to those holes. So I'm going to choose the next option. Now, inside of next, we get our choice of our cutting conditions, and whether or not your machine has a database is going to depend on your machine. Mine has a database, so I can define the offset, the power setting, and the feed rate, as well as any speed and tension for the wire. If you need to edit this, don't edit it now. And the reason I say this is because on the edit table, when we're on this, all we see is the rough and the single skim pass, but I want to do 3 skim passes. So I don't actually get a chance to set up my skim passes until I get to the next page, which is the skim. So the reason I say don't do it then is because the last page of the entire job is another cutting conditions page that I can go in and make my modifications to. So I'll do a standard profile. We have a choice to just flip the pass direction. So if we went clockwise on the rough, it's going to go counterclockwise for its first pass on the skim. And then with the skims, we could either say run them all in the same direction or reverse the directions as they cut. I'm going to run them all in the same direction, and I'm going to set their number of passes to 3. And then again, I'm using machine compensation, and I didn't set any stop points. So next again. Corner types, just going to leave them on sharp. Just going to let it cut based on what the geometry shows, and that's primarily what you're going to use the sharp for. Right here's my leads. Once again, I do want to use the same leads. So what I'm going to do is instead of having to go back and repick all those points, I'm going to go up to the leads page for the rough pass, and I'm going to say apply to all operations. And what it does is it copies the leads page from here down to here. So now we'll see I have the same lead in and lead out points. Next again, we have our cutting conditions. So again, this would be the page that if you were going to set up the offset, the power setting, or the feed rates for any of these tool paths, this would be the page I do it on, because if I go into the table now, I get all of the passes defined, not just that initial pass, or not just the initial rough and skim. So now I can hit OK. When I'm all done, I can hit compute. And you won't see much on the top view. That's what's really nice about having this perspective view. But there it is right there, just going around making its cut. There's all our leads. You can see all the lines for those leads just connecting in. And then that's it for the interior cuts. So now I could go in and do the exterior cut, but I want to look at my stock real quick because I want to pick a good spot. Probably one of these top edges right here is where I'm going to try and do my lead for this so that I'm off the part. So I'll right click, and this time I'm going to do a 2-axis outside. So I'll select my geometry. I'm going to pick that piece of geometry there, which I've joined together using the join function of RHINO, so I can pick the one thing. Otherwise, if it's broken, you brought it in as a DXF or anything like that, you will have to pick each individual entity. And then right here, I'll pick my chain, and I'm just going to go in and zoom right on this corner and pick it right there. All right, and I'm also going to flip the direction of it by clicking the tip of the arrow. So I want it to be a G41 compensation to the outside. So that'll get me to go to the outside of the part. And then I just have to make sure I have a lead that's long enough to go off the stock. When I'm done, I can hit OK and then go next. Now with this one, we got our upper lower guide, whether or not we're using glue stops. So I'll do a glue stop this time. We have our stop distance. So how big of a stop do we make? And then whether or not we're tapering. We don't have a land and taper on the exterior cut, on the outside cut. So I'm going to leave that to none. Right here, I'll choose my strategy of a rough cut, a skim cut, and a tab cut. So I'll go next. Right here, we have our wire information and our posting. So with posting, we still have the arc spline output, the work offset, the posting order, but we could say, let's do our tab cuts last so that we can wait till the end to cut those. Right here, we then have our sequencing. Again, I'm just going to go in the X direction. It's only one part, so it really shouldn't change too much. I've picked my start point already. Right here, we have our standard profile, system compensation off, machine compensation on. Our corner types, I'm going to leave those on sharp once again. Our leads. Now for the leads, I just need to make sure the leads are long enough to get off the part. So I'm going to go in and just set up a circular lead in, and I'm going to make the radius a 1/4 inch, and I'm going to make the length a 1/4 inch. And that should be plenty to get me off the part so I can run the wire and then just start from the outside into the part. Right here, we have our cutting conditions. Again, ignore this because the last page is going to be the cutting conditions. That's where we could set them all up if we have to modify them, or it's where we get to see them all if we have the database. Right here's our parameters, so we can start with a standard profile. I'll do 2 skim passes. System compensation off, machine compensation on. I want that G41 and G42 to output when I need them. And I'll even do the reverse skims on this one. Right here is our corner types again, our leads once again, and our cutting conditions once again. So I want to do the same kind of thing with the leads. I'm going to set this up as a circular. I'm going to set the radius to a 1/4 inch and the length at a 1/4 inch. And then go next. Cutting conditions, once again, wait till the end. And then we have our parameters for the tab cut. So we could say, use the standard profile. We could flip the pass direction. We could even use a knockout to go in and knock it out. But I'm just going to flip the pass direction, machine compensation on. For the leads, I'll go just perpendicular at 100 thousandths. And then right here's our cutting conditions. This would be the page that I would finally go into my edit table here and put in any of the values I need to enter in. Otherwise, I'll just hit OK and hit compute. And once again, there's our cut. You can see our leads right there all the way around. So now we could go ahead and launch the simulation. So I'm just going to go up to Start Simulation right here. Remember, it's going to launch into whatever screen you're active on. So I'm going to double click on the top here first and then launch the simulation. Now, when the simulation for Wire EDM launches, one of the best things you could do is turn on a setting in here, which if I expand this down and I go to visibility, you could turn on machine housing. And this is just a good way to kind of see what's going on. You can see the guides of the machine kind of cut, and it just helps out for kind of viewing everything. So I'm going to slow this down and say run. We're going to see there's our first arc, skim passes. There's our second. There's our third, fourth, fifth, kind of reset there. There's our first skim, second skim, third skim. And it's just going to keep going around doing the same thing. There's our inner pocket. There's our extra holes. And then when it gets to the end of this, it's just going to start on the outside over here into the part. And we can see it starts off the part. That's perfect. That's exactly what I wanted to see. It's going to go in, keep cutting all the way around. And then it's going to go ahead and lead out right there and then reverse the skim back. And I'm just going to fast forward. So it goes and cuts everything. Now, in the simulation video that you'll see I did the milling part in, I didn't have the ability to remove this stock from here because I didn't have any extra stock. But with this one, if I rotate it, we'll see the cut goes all the way through, but I still can't really see what the final result is. I know what it's going to look like, but I want to see what the final result's going to be. So the tab we can go to is over here. It's the Measure tab. And in here, there's an option called Remove Chips, and either you select chips, or in this case, I'm going to choose this option that says only keep one part. By doing this, I could go to my part inside the simulation window and click on it with my middle mouse wheel like it's a button. So I'm just going to click that middle mouse wheel in, and anything that's not connected to the part will disappear, and this is what I should expect to get at the machine. So we're using that wire. We got a nice sharp corner in the corner there. Basically, the remove chips went in and just gets rid of all the areas that would have fallen out anyway. So there we go. We have our entire part done. And again, when we're all done, we can close it out. And then to generate the code for this one, the big thing is make sure you have the right post processor, right machine. You can switch the machine if you need to, but just know the database does not transfer between machines. So if you pick the wrong machine at the start, it's not going to transfer into the new machine. You'd have to go back and reset up all your cutting conditions. But all we have to do is right click on Wire EDM job and say post. And there is the code for all of those cuts. And that concludes the video on the Wire EDM tutorial from inside of BobCAM for RHINO.